Yeah, good morning all. Now I am going to explain about polar plot. Okay, now see here in this polar plot, first of all I am taking a open loop transfer function, that is g of s into h of s is equals to 1 by s plus 1. Okay, to draw the polar plot, okay, first we need to find out the angle. Phi is equals to, see here, 1 by pole, right? That is nothing but minus tan inverse y by x, right? S is equals to j omega, that value will be omega by 1. Okay, now see here, to draw the polar plot we need to consider angle. Okay, 0 degrees in anticlockwise direction 0 degrees, 90 degrees, 180 degrees, 270, right? In clockwise direction negative values 0, minus 90, minus 180, minus 270. Okay, you can remember this point. Okay, now see here, if I substitute omega is equals to 0, what is the value? Phi is equals to 0 degrees. Okay, that is omega is equals to 0, it starts from 0. This is 0, right? 0, minus 90, minus 180, minus 270. If I comes like this, 0 plus 90 plus 180 plus 270 degrees, right? Omega is equals to 0, tan, this value will be 0. When omega is equals to infinite, minus tan inverse infinite value will be minus 90, right? This is 0, this is 90. That means omega is equals to 0. Here it is omega is equals to infinite. That means polar plot will start from 0 to infinite. Okay, in this way we can draw the polar plot for 1 by s plus 1. Similarly, g of s into h of s is equals to 1 by s plus 1 into s plus 2, right? Then angle will be phi is equals to minus tan inverse omega by 1, right? For this pole, minus tan inverse omega by 2. S is equals to j omega, right? That means if I substitute omega is equals to 0, it starts from 0. Next, omega is equals to infinite. This is minus 90. This is minus 90 degrees, right? This value will be minus 180. That means it ends at minus 180. Okay, similarly g of s into h of s is equals to 1 by s plus 1 into s plus 2 into s plus 3. That means angle will be here, when omega is equals to 0, angle is 0. Omega is equals to infinite, minus 90, minus 90, minus 90, 280. Okay, in this way we can draw the polar plot. Okay, similarly for g of s into h of s is equals to 1 by s into s plus 1. Okay, that means first 1 by s is nothing but minus 90, s plus 1 minus tan inverse omega by 1, right? That means here omega is equals to 0, which starts from 90 degrees. Omega is equals to infinite, ends at minus 180. In this way we can draw the polar plot. Okay, for this plot k into e power minus st by 1 plus st, right? For this exponential function, in this way we can draw the polar plot. Remember this point. Okay, after that, gain margin and phase margin of a system. Okay, to calculate gain margin, okay, gain margin is always calculated at phase crossover frequency. Okay, whereas phase margin is calculated at gain crossover frequency. Okay, now see here, now we will solve one problem, how we can calculate this gain margin. Okay, let us consider a transfer function, that is g of s into h of s is equals to 1 by s into s plus 1, right? Now see here, what is the step 1? Okay, to calculate gain margin, first phi is equals to minus 180 degrees at omega is equals to omega pc. Okay, that means phi value, right? How to calculate here phi value? Phi value is equals to minus 180 degrees. This is step 1 at omega is equals to omega pc. Okay, that means here phi is nothing but how to calculate this phi value from this equation, right? 1 by s value will be minus 90. 1 by s plus 1 value will be minus tan inverse omega. Here omega is equals to omega pc by 1 is equals to minus 180 degrees. Okay, now see here, at what value of omega, this value minus 180 is equals to minus 180, right? Minus 90, if this value should be 90, then only this value equal, right? That means when omega pc is equals to infinite, this value is 90 degrees, right? Tan inverse infinite is nothing but 90, right? Minus 90 minus 90, you will get minus 180. That means omega pc is equals to infinite. That means first this is phase angle, Okay, we need to calculate gain margin, right? To calculate gain margin, first we need to equal phi is equals to minus 180 degrees. Okay, if I equal this value, omega PC is equals to infinite, right? This step is completed, right? After that, step 1 is over, right? After that, magnitude of g of j omega at omega is equals to omega PC. Okay, that means step 2, magnitude of g of j omega into h of j omega, right? That is 1 by, here s, that is nothing but omega under root 1 plus omega PC square. Okay, already omega PC value is calculated, right? That means 1 by infinite value will be 0. Okay, step 2, magnitude of g of j omega into h of j omega value is 0. Next, step 3. Now see here, step 3, gain margin is equals to 1 by magnitude of g of j omega, right? That is 1 by magnitude of g of j omega into h of j omega. Here I assume h of j omega value is 1. Okay, already this value, magnitude, this value is calculated, right? That value is 0, that is 1 by 0, that is infinite. Okay, when omega PC is infinite, gain margin is also infinite. Okay, clear, right? In this way we can calculate gain margin. Okay, to calculate gain margin, step 1 is we need to equal phase angle is equals to minus 180 degrees. At that point we need to calculate phase crossover frequency, gain margin. Okay, gain margin always calculated phase crossover frequency, right? That means first we need to calculate phase crossover frequency. After that, that phase crossover frequency will be substituted in magnitude of g of j omega into h of j omega, right? You will get here magnitude of g of j omega into h of j omega. 1 by magnitude of g of j omega into h of j omega is nothing but gain margin. Okay, here gain margin is infinite. Okay, similarly phase margin. Okay, same problem. If I want to calculate phase margin, okay, what is the step 1 in phase margin? Magnitude should be is equals to 1, that is 1 by, that is magnitude of g of j omega into h of j omega is equals to 1. Okay, to calculate phase margin, first step is this one, that is 1 by magnitude of omega is nothing but omega into 1 plus omega gc square is equals to 1. Then omega into under root 1 plus omega gc, that this is also omega gc, right? Square is equals to 1. Okay, that means from this equation first we need to calculate omega gc. Okay, that is step 1. Okay, next step 2, calculate phi value at omega gc, right? In step 1 already phase margin is always calculated at gain crossover frequency, right? For example, just for assumption, for your understanding purpose, I am assuming this as 1 radian per second. Okay, omega gc value is 1 radian per second, right? That means here phi value will be minus 90 minus tan inverse 1, right, from this omega gc. Then minus 90, tan inverse 1 value will be 45, right? Then phi value will be minus 135 degrees. Okay, that means step 2 we need to calculate phi. After that, step 3, phase margin is equals to 180 plus phi, that is 180 degrees minus 135. Okay, then the resultant value is 45 degrees is the phase margin. Okay, in this way we can calculate gain margin and phase margin. Okay, to calculate gain margin, in gain margin step 1 is first we need to equal phase angle is equals to minus 180 degrees at phase crossover frequency. Okay, that means there you can calculate omega suffix pc. Okay, substitute that omega suffix pc in magnitude of g of j omega into h of j omega. Okay, you will get magnitude of g of j omega into h of j omega value. Okay, after that gain margin is equals to 1 by magnitude of g of j omega into h of j omega, you will get gain margin. Okay, next phase margin. To calculate phase margin, magnitude should be is equals to 1 at gain crossover frequency, right? Here you will get omega gc value. Assume here 1 radian per second. Okay, after that calculate phi value at gain crossover frequency. Okay, from this equation, what is the phi value? Minus 90 minus tan inverse, here omega gc value, right? Omega gc value will be 1. Tan inverse 1 value is nothing but 45 degrees. You will get phi value as minus 135 degrees. Then phase margin is equals to 180 plus phi. You will get 45 degrees. Okay. In this way we can calculate phase margin and gain margin. Okay. From these two results we can find out the stability. Okay. If gain margin and phase margin both are positive, then the given system is stable. If gain margin and phase margin both are negative, then the given system is unstable. Okay, if gain margin is 0, phase margin is 0, then the given system is a just stable. Remember these 3 points, very important. Okay, next to see here, if g of s into h of s is equals to 1 by s into 1 plus st1 into 1 plus st2. Suppose for this problem, direct shortcut is, if I want to calculate phase crossover frequency, that is equals to 1 by under root t1 into t2. Then gain margin is equals to t1 plus t2 divided by t1 into t2. Okay. Now, from already we know how to calculate gain margin and phase margin, right? Now we will see how to calculate gain margin and phase margin from the Bode plot. Okay. See here, this is magnitude plot, right? This is phase plot. Now see here, this is magnitude plot and this is phase plot, right? Okay, that means gain margin is calculated. Now see here, gain margin is calculated always at phase crossover frequency, right? This is phase angle, right? Okay, that means this is phase crossover frequency. At this phase crossover frequency, we need to calculate gain margin. Next, similarly, next phase margin is always calculated at gain crossover frequency, right? See here, this is the magnitude of g of j omega, right? This for magnitude of g of j omega, this is the gain margin. This value is negative, right? But gain, what is the formula of gain margin? That is equals to 1 by magnitude of g of j omega into h of j omega, right? Okay, in terms of dB 20 log 10, 1 by magnitude of g of j omega. Okay, that value will be minus 20 log 10 g of j to minus 20 log 10 magnitude of g of j omega. See here, your gain margin will be negative, right? That means here also negative value. Minus into minus, you will get plus 20 dB per decay. That means, just to remember here gain margin is negative, means final resultant gain margin should be positive, right? Here it is in negative, right? This is magnitude of g of j omega, right? When 1 by g, if we consider 1 by g of j omega, that value is, here it is negative, means gain margin is positive. Similarly here, omega gc, right? Here phase margin, right? Now the already we know that phase margin formula is will be 180 plus pi. Okay, assume here phase margin phi angle will be minus 100 degrees, right? Minus 100. Then phase margin is equals to 80 degrees. 180 minus 100, you will get phase margin as 180 degrees. Okay, this is from Bode plot, calculation of gain margin and phase margin from the Bode plot. Next, gain margin and phase margin from the polar plot. Now see here, this is minus 1 comma 0 are the intersection points. Okay, for stability, minus 1 comma 0 should be enclosed by a polar plot. Okay, here it is not enclosed, right? Here it is enclosed. Okay, but for a stability should not enclosed by a polar plot. That means it should not enclosed, right? That means it is a stable system. Here it is enclosed, right? Hence it is a unstable system. For a stability, minus 1 comma 0, okay, intersection point should not be enclosed. Okay, hence it is not enclosed, right? This is the enclosed path. Okay, here it is enclosed, hence it is unstable. Okay, in this way we can determine the stability. Okay, thank you all.